Today we'll be talking about trends in the HVAC industry. Our presenters are Raul Dominguez and Adai Rodriguez. We have a chat session. Please feel free to place your questions here and we will do our best to answer those during the webinar or at the end of the session. Without further delay, we'll begin. Thank you.
Hello, my name is Raul Dominguez. I will start with this. I'm an associate FAE. So for today, we will see the next agenda. We will check the basics about the HVAC systems, basics, evolutions, some of the trends, the efficiency, the new things with the disinfection needed, what are the communication solutions that we can find, all the sensors and how all of these are coming together to give some intelligence to the systems. We will also check some components that can help you in your designs. Next, please. So HVAC stands for heating, ventilation, and air conditioning. This technology is only focused on provide thermal comfort to the humans in an indoor environment. Sometimes there's also the part of the air renewal needed to confer health conditions. Next, please. These systems are important for residential and industrial locations. We can see them in small homes, apartments, hotels, medium to large industrial and office buildings, in all kinds of vehicles. We can see them in cars, trains, airplanes, sometimes even in motorcycles. Next, please. So for heating, there's a heating element that its whole purpose is to increase the temperature. And then we will see the increase in temperature inside the room. For ventilation, we see that there's the air renewal in enclosed areas. For that, we have the air extraction and air supply. And sometimes we need to go beyond that. So we need positive and negative atmospheres depending on the quality required by the industry. We need to ensure the indoor air quality. Therefore, we need this kind of ventilation. For air conditioning, normally we say, hey, we need to cool the area. But what we really do is do a heat exchange. We remove the heat from the inside, transfer it to the outside. That's what an air conditioner does. Next, please. What types of HVAC we can see? We can see heaters and air coolers, commonly used as mentioned in housing and in apartments. Those are normally single stage systems. We can see also multi-stage systems, which we can see in a single unit, both the heating elements and the cooling element for the environment. And finally, we see the sound systems. This is another variety. This is used in huge areas like buildings, industrial, commercial. We have a central systems, and with the ducting, they select which area receives more of the comfort or the treated air, heated or cooled, using some doors and managing the airflow through each zone. This prevents the system from overheating, overcooling certain areas. Next, please. In the classification, we can classify those in three. We have the split units that are also common with the window AC systems. These are commonly seen in homes and apartments. This includes an indoor unit and outdoor unit. In the window, it's in the same. The window unit, one part is on the outside, one part is in the inside. What we can see in the outside is the condenser, the compressor, some electrical components, a fan. And in the inside, normally we see the control, the thermostat that is intended to manage the system. We have the packed heating and air conditioning, that in a single hybrid unit, we can see both the heating and the cooling element, and we can set the temperatures accordingly. And central systems, sometimes we can see hybrid systems in central systems. There's a big unit that does the cooling and another one that does the heating. And through the ducting, it splits through the different zones in the indoor portion of the building. Next, please. So in electronics, we can see this, the basic block diagram. We have the power supply, the AC, DC. Then we have DC, DC or LDOs to go in a lower voltage. We have the main processing unit, the microcontroller. We have buttons to interact with the user. We have displays to show the set temperature and the current temperature. We see several connectors. Sometimes we see wire communications, the old ones, the RS485 or PLC. And then we need to control the motors. For that, we have relays or solid state relays, or even some drivers. Next, please. Now, more commonly used the wireless communication, we see it more and more. We have the Bluetooth or Wi-Fi modules, and those modules will need an antenna. So depending on the type of communication needed is the type of the antenna, also the range that it needs to cover. Next, please. And now, going smart, we see more and more sensors that are being used. We have the motion sensors or occupancy sensors to enable or disable the unit to reduce operation cost. We can see also peripheral thermometers, because we don't want to check only the temperature at the unit. We want to see it, for example, at the bottom of the room or certain areas, and we want to control that portion. Next, please. So now I will talk about the trends that we are seeing on the industry. Thank you.
Thank you, Raul. So the idea for this webinar also is to talk about the trends, the evolution of these technologies. As we are receiving or seeing more implementation, new technologies, for example, within the electronics industry, we will see those, or we are seeing those, as Raul already mentioned on the previous slides, on how the communication is implemented, and of the reasons for these communications to be implemented, the sensors, why do we need the sensors? So we can talk about, when we talk about trends, we can refer to the different new type of gases or new type of mechanical components, mechanical materials that can be used in this technology, in these HVAC systems. Talking about electronics, we will find different kind of new trends, but for this webinar, we have identified some things that we think can be or maybe are already implemented in these technologies, in these systems. When we talk about trends in the electronics, we will find disinfection systems, efficiency, not only for the PSUs, also for the motor control. Talking about the sensors, this can be used for some controls, and this is all related to the communication and maybe intelligence, providing more intelligence to the systems so they can connect with each other and identify trends on how the people of the users use these systems. Talking about efficiency, this is related to the industry's requirements. The idea is to produce or consume less energy. So, and this is all based with the requirements of the industry. So when we talk about efficiency in these systems, we can refer to power supplies and motor control. And for power supplies, we can talk about not only the individual control units, but also when we go to big corporate buildings or big facilities, we can identify some cabinets with relays and some other control units that might require a power supply. So it's not only about the one simple stage. Also for the motor control, we'll see it on compressors, fans, ventilate, or the system that control the ventilation systems, okay? Talking about power supplies, this is what I already mentioned. We can also refer to the power supplies not only for these small systems that we know in some cases can be powered by batteries. In some other cases, maybe they are controlled or powered directly by the AC power line. But also on big systems, on corporate big systems, central systems that Raul already mentioned, we can use the identified power supplies for this one. The trend for this is to improve the efficiency, reduce the size. So we can use it, maybe this can be done also by changing the technology of these power supplies. Instead of using linear components, linear transformer, for example, we could change to switch mode power supplies that can help us on reduce the size, the weight, of course, without a requirement, maybe the lack of, or without using more heatsink, for example, we can reduce the weight of these designs, and of course the efficiency, which with new technology implementations can be used with the silicon carbide or GaN technologies. When we refer to power supplies, we can, depending on your application, of your requirement, you will find, or you might see that you will need maybe a module that can be easily plug and play into your board, or maybe you can use a discrete solution. It will always depend on your requirements. For modules, we can find some modules that are already fixed with an output, a fixed output power, output voltage, starting maybe from the most common 3.3, 5, 12, 24 volts DC, with also output powers from 1 up to 20 watts. In some cases, we can identify series or families with normal universal voltage AC input, or in some cases, new technologies or new families that can help us to support more input voltage. New technologies, new families can help us with new things to implement, or new things that are implemented in these systems, like zero cross detections. Talking about smart homes, in some cases, the need for detecting when the AC line crosses the 0 point is needed by the MCU. So this, some power supplies might already implement this. When we refer, not only, we can talk about not only the modules, but if the requirement is different, we can go and use maybe a discrete solution. Maybe for the control units within the rooms, or maybe for the cabinets, okay? We can work with or we can design our own power supply that can be designed for our specific requirements. Maybe universal power base voltage AC, yes, but as we know, for these kind of locations, for this kind of industry, maybe the 24 volts AC is more common. This can help us, these power supplies or discrete power supplies can help us on customize depending on our requirement. We could use GaN. There are many technologies, or we can identify silicon carbide, GaN technologies. So GaN technology can also be implemented, or can be implemented in these power supplies, big power supplies with output power. So in order, we can reduce the size, we can increase the efficiency. As we are showing, the size can be reduced more than half the size. And of course, we can not stop using maybe, or reduce the size of the heatsink. So it's all related: size, weight, and of course efficiency. talking about keeping, when we are still talking about efficiency, we can refer also to the motor control. The new requirements from the industry are leading the new trends, the new technologies or designs to for the motor control. We also will see the new kind of motors, or some motors that were not commonly used in this technology, be the BLDC motors, that can be controlled by new electronics. We can implement a better algorithm. We can implement some new technologies, also silicon carbide GaN, to reduce the size, to improve the efficiency in order to comply with these industry's requirements. For motor control, I already mentioned this, but new technologies that can be used are silicon carbide, GaN, which can help us with higher efficiency, size reduction, or the use of other kind of motors for this application. And the idea is also for this webinar is to talk about not only the big location, the big facilities, also to remember that we can identify, as we previously mentioned, that HVAC systems not only refer for big location, but small locations, residential usage, and even vehicle applications. For motor control, depending of the requirements, we can find modules, or we can find discrete solutions in which, for example, we can use IGBTs, like the technology that is being used most of the time on these products, but also silicon carbide. Silicon carbide with MOSFETs and Schottky diodes. We can find also many benefits of the silicon carbide technology: higher switching frequency, lower switching losses. We can work at higher temperatures. The efficiency, of course, the size, the lack of heat sinks, for example. And this is all related, of course, with the gate drivers. For these technologies, we all know, we just need to remember, we will need some gate drivers. These normally silicon carbide and GaN technologies require a different kind of drivers. So that is another thing we should consider when we want to implement this technology. GaN technology also can be also implemented on motor control for higher efficiency, for a better, fastest control of the unit, and of course it will be related to, or we should not forget about the drivers for this specific technology. Talking about another trend, we will find air purification. So a little bit of backup for when we talk about air purification, we will find filters, or can be the normal filter that we find on the industry, but also electronic, or some others that implement also electronic components for photocatalytic oxidation, or filters or systems that use chemical processes. In this case, we will find in the next slides that are also related to the use of UV light. The filters we already find in the system, in the industry, different kind of filters that can be used in common or as a complementary solutions. HEPA, or high efficient particulate arresting, that allow us to or don't allow components with a size higher than 0.3 microns. They can be also be used with carbon filters that normally are used for odor control, or remove the odor within the air. Also, we can find electrostatic filters that with the charge, electrostatic charge from that normally is from factory, attracts the components. So it doesn't allow the small particles to keep in the air. This is also related to the electronic air cleaners, which work kind of with the same principle, creating an electrostatic field, an electrostatic field, or that can allow us to, or don't allow to the use of or the move of these components, particles. The new technologies, or some new technologies, or some other technologies that are being used in this for the air purification are the PCO, photocatalytic oxidation, that, as I already mentioned, is commonly a mechanical process that reduces the amount of particles are components that can damage the human body. This is also being used as a complementary solution with the UV light that allows to keep the air clean. Normally, this component, or the air, is passes through a box, for example, talking about maybe a kind of a box in which this mechanical process and the UV light process is being applied. So the air is being cleaned and moves to the next stage of the unit. Also, UV light can be used as a complementary solution of this kind of filters of technologies, but also can be used as an individual technology or individual component for these systems. We will see some suppliers, some new technologies, or some more companies using this kind of light for air purification. When we refer to technologies that can be used for UV purification or air purification, we will find again modules. In this case, UVC light that can be provided within a module, or an M module, or a discrete kind of discrete solutions for the user to put it into their own system. We can also see if we want to implement a discrete solution, we will find some other technologies that can help us on the design of our own technology, providing not only UVC, but also UVC A or B. Normally, we are aware, or we have seen in the market, that UVC is the most common, the most common technology used in this for the air purification, but some studies that we have identified also help us to be aware that UVC-A or UVC-B can also be used for this for air purification. So we can help you. We can identify some products that can help us, or can help you to implement this kind of technology into your designs. So this is what we were talking about, not only UVC, but also UVB or UVA. The LEDs can be used for the air cleaning process. Another trend refers to, and is related, of course, to wireless communication and to the implement of intelligence. The use of sensors is also can be used, for example, in this case, for motion and occupancy, for some control, but not only is for that purpose. Or we can use these sensors also for the efficiency of the entire system. We can turn off the system when we don't detect any people, any person within the rooms, or only maybe we can turn on the systems when we identify people that are maybe not only at 5 meters but in on less distance. Or gradually be increasing the temperature or reducing the temperature of the room as the people or as the users approach to the room. Okay. When I say this is all related, is we can use wireless that we will talk about in a couple of slides, but we can use the sensors, not only occupancy, but some other kind of sensors to send information to the central systems or to the user, to their smartphone or to the computer, not at that location, but in a different location. So all these sensors can help us to that. We can find not only motion, but also presence or occupancy, which with other technologies, as we have talked in previous webinars, with normal technology, if I stop moving, the sensor will stop detecting me. I will need to move my body, wave my hands in order for those technologies to detect me. With this kind of microwave sensors, I can stay stood, or it's not necessarily for me to move. The sensor will still be detecting me. Or we can even implement more information or more things in these sensors. For example, people counting or measure the distance of the people within the room, as I mentioned, to increase or reduce the heat within these locations. We will find two different kind of sensors, working at 5.8 gigahertz for occupancy, motion, or vital sign, or 10 gigahertz for the same occupancy, vital signs, and even distance. So, well, that would be one of the sensors we can provide. For the other ones, Raul can help. We'll continue the presentation.
Now we will see some interface solutions that we can offer. Here you can see the traditional thermostat, the old ones. You have the push buttons, tactile, all. Now with Azotec, we can help you to become new, to go more high-end with the capacitive sensors, inductive sensors, Hall encoders. So with this IC, or even if you need the board, we can do it. You can implement several things. So you can have a proximity wake up. So you can dim the light, and when the people is going near push the buttons, it can light up. We have the touch buttons. You can implement sliders. Even we can implement gesture pads. So you can have a square or a circle and design something that can detect up to 5 fingers. So you can create your own gesture pads. For the inductive sensors, we can implement touch over metal, the contactless switch, because you can have a metal inside and detect the deflection of it if it's having force. With that, you can implement tamper-proof systems. So you can detect if someone is trying to open the device, meaning opening the full air conditioner or opening just the control unit. You can implement a way to detect it, and you can react to it. Also, you can have a Hall encoder to implement a mechanical dial, so you can switch, turn around. You can do the rotational sensing with capacitive wake up, so it's not a mechanical, but you can slide your finger like a rotational dial, or you can have a mechanical wheel on the inside. Next, please. So what we can do, here you can see more on it, where it says inductive switch, it's that nothing mechanical there. You will push behind the plastic, there's a small metal, and we will detect when force is applied. So you have a waterproof switch without being a switch. You can have the rotational knob, you can make a trackpad wheel on the side, the proximity backlighting, because it will detect when you are putting your hand near it. You can even, if it's a thermostat that is battery powered, you can send everything to sleep and just wake up when it says the proximity. So it will help heavily with the battery powered solutions. Next. And now we're going smart. We know that the industry is or was slow moving. Now with everything going interconnected, we're seeing the famous big data. We have the IoT, Industry 4.0, all the connectivity. Everyone with a smartphone in their hands wants to control everything. Now the air conditioning, the HVAC systems are going toward that portion of the technology. Next. So we have two flavors, going wired or wireless. Normally, in the old HVAC systems, we can see the wired solutions. The cons are you need to place the wiring, you need to buy the wiring, so it's normally more expensive. But now we have one offering that can help you. We will see in a couple of minutes, that can save you the wiring and use the communication. And also for the wireless, you can see that everyone now wants to monitor everything from a tablet or a smartphone or a computer or a server. So you need to communicate. So we are seeing more and more the wireless, even for some home appliances. They are starting to sell the add-ons to become Wi-Fi or Bluetooth. And with that, we start communicating the behaviors, and we can implement a central system or a edge system that can learn the user habits and start performing towards that. Also, another thing is for maintenance, the industry is starting to implement the self-diagnosis. So for example, for all the motors, the predictive maintenance is being done, and what you need to communicate. You can sense how is behaving the motor, if it's the vibration and everything, currents, voltages, how it's behaving. Now you need to communicate to a central system, so the technical guy or the user or the owner knows that he needs to do something to prevent the fails. Next. So we have in communications, wired and wireless. What do you need to consider between that is maybe you can use both, or maybe you need one or the other. For example, for wired communications, we can offer you this GHN. The GHN communication, the good thing is that you use the existing infrastructure. You can use the telephone wiring, coaxial cable, and even power lines. And you can get speeds up to 2 megabits per second. So this, you don't need to buy extra wiring. You can use what you already have to do the automation. You can go greater distance and several nodes. There's, depending on what you are using, the noise immunity. And the good thing is that you can have greater communication speed. So even you can mount like an Ethernet using the GHN. So with the GHN devices, there's a kind of an Ethernet output. So you can distribute more speed, more data using the same wiring system you have. Next, please. And for the wireless communication, it's depending on what we need. Maybe we need direct communication. So we have a control or a cell phone that needs to connect directly to the device. That's the direct communication. Normally we see Bluetooth and Wi-Fi for that. Maybe we need indirect communication. That's we have separate control thermostats. And for that, we can see Bluetooth, Wi-Fi, but we can also see Bluetooth mesh, for example, or Zigbee, because we will need to communicate several devices in a chain or in a very wide area. And these communication protocols help us to do that. And if we go smart, let's say we start implementing more complex systems. Some can be homemade smart systems. For example, using Alexa to turn on your air conditioning. So we will see there Bluetooth, Wi-Fi, but we also see HomeKit there. So to start implementing everything. Next, please. So for direct and indirect communication, we can help you with U-blocks. We have modules that can be or Bluetooth or combos Bluetooth Wi-Fi. We have different form factors with different power of that. We have those that are already controlled using AT commands. So it's an easy deployment, easy, you already have your microcontroller, you just need to connect serially to the module, use the AT commands, and you will be enabling the Bluetooth, the Wi-Fi, or both. So this helps you with quick time to market. The bad thing is that you need an external microcontroller. Down here, we can see a couple of modules, form factors. We have these NINAs that are very common, that have the Bluetooth and the Bluetooth Wi-Fi combo. We have smaller ones like the gray with a black. It already has an antenna embedded there. It's small, and we have the Bluetooth there. In the right side, you can see how is the communication. It's the self-called Hvac Express. Within the module, you have all the stack for Bluetooth, Wi-Fi. You have the Hvac Express and the AT command interpreter. So you will have a serial interface. You will send on commands, and it will connect. Next, please. If you want to go and save some dollars, we have the Bluetooth Wi-Fi Open CPU. The benefit, no external microcontroller required, so you save that portion. There's a very cost benefit there, but you need a longer development time because the microcontroller inside the module is ready to be programmed. So you need to use the stack provided by the chipset vendor, and then you need to program it accordingly to your needs. So you can use it as a central processor unit for your module or for your device, and also do it for communication. Next, please. We also have, if you need more Wi-Fi and Bluetooth power, we have these that are called host-based. This requires external processors that are normally used in Android or Linux. So you have more power there. Even you can mount or create a Wi-Fi router using those models. So these are very powerful, but you need an external processor. Next, please. And if you have a good programming staff and also some RF experience, you can save more going to a chipset. For that, we can offer Telink. Telink is a worldwide known Bluetooth chipset. It has more than 23% of all the world Bluetooth communications. And with that, we can offer different options from multimode protocol, Bluetooth, Zigbee, Bluetooth Classic, Bluetooth Low Energy, Bluetooth Audio. So if you can or have the capabilities for this programming and want to save more, we can help you with these chips. Next, please. Benefits, better cost. It's a greater design challenge. The chipset already have the HomeKit. It has a 32-bit RISC MCU inside of it. We have more power with a RISC-V availability. New ones that are coming with extended options for artificial intelligence. It's called, what is called the smart edge computing. Because, for example, now you have the Alexa, but if Alexa doesn't hear you, then you will need to buy one Alexa for each room. But if you are implementing, for example, your air conditioning and tying to Alexa with these new high power processors, you can do some kind of command interpreting because they have DSPs, and you can do the programming to understand small things, send the commands to a central unit, and then behave like you want. Next, please. And if you have wireless communication, then you will need antennas. You cannot go away from those. We have several types. We have internals, we have externals, we have outdoors. If there's a very small unit, we can do custom embedded antennas, like you are seeing in the left side. These squares, those portions are custom antennas. We have all the accessories you need for going wireless. The antennas, and also if you are designing your own discrete RFs, we have this LTCC portion where you can see balloons, bandpass filters, low pass filters, couplers, duplexers, triplexers. We can help you with the inductors, we can help you with the capacitors. So depending on what you need, we can help. You can go with modules, we can help you with modules, you can go with discrete and the chipset, we can help you with the chipset and all the discretes. Just tell us and we are here to help. With antennas with pulse, we also, as a service, when you select a pulse antenna, we do a design review and we do the tuning and matching of the antenna. So that will help. Also, if you need to do a pre-certification, we can do some testing. This will cost only the testing. The design reviews and the tuning are free when you choose a pulse antenna. Next. Here is our spot of a picture of our tuning lab when do all the antenna matching and no cost for you. Next.
So when we talking about or keep talking about intelligence or the implementation of intelligence, we need to remember we are not only referring to the control units that are placed in the walls. Maybe we can work on centralized intelligence inside the locations, for example, for the cabinets. And when we refer to those kind of products, the cabinets, we can identify some products that we can help you for implementing the technology with AI. There are some different flavors, different sizes, or different motherboards, embedded computers that can be used for these applications. These embedded computers has the capability to implement some external or some other models, wireless communication, LTE, Bluetooth, Wi-Fi. So we will find also modules for implementing artificial intelligence. So not only for edge computing, but maybe centralized within the location, we will find some this technology can be very useful for you. Keep talking about maybe edge computing. The trend or the requirement to implement more intelligence to the local devices within the rooms, for example, are leading us, for example, to implement solutions, processor with more processing capabilities. We already see the processors offered by Telink, but we can see the use of FPGAs that can be applied for these products. We normally see microcontrollers, but we shouldn't forget the advantage in some cases of using FPGAs, different kind of programming or programming style, but the intendance for this is the same. Implement different technologies when we need to when in cases when the processors or microcontrollers are limited by peripheral communications, FPGAs can help us to implement more protocols, more interface. We are seeing in this case, well, when we need more than one IC square, it's just an example, but when we need more than one IC square peripheral with FPGAs, we could be able to implement more than 1, 3, 4, 5 within the same chip. And well, that is all about the technology trends, technology solutions that maybe we could be able to support you. We need to remember that there are some other technologies that can help on your design or your implementation for these kind of products. We need to refer again to the block diagram that we showed before. And we are aware, and you know that we will find different kind of block diagrams, different solutions that will depend of the entire of the end product, the final application. This is just an example, but referring to this, we'll find some other products that can support with you on your design. Protection devices, fuses, source protection devices, MOBs, GDTs, some other mixed technologies fused with MOBs, for example, some other more or some components more complete, time delay relays, voltage monitors, temperature, even temperature components. Some things that maybe you are already considering, but just as a reminder that we can help you on this. Some other technologies or some other suppliers that can be used for this is thermostat, industrial thermostat, industrial breakers, for example, that will be complementary for your solutions. And of course, the relays. We will find on some catalogs, in our catalog, a different kind of families, with different kind of part numbers. We can help you identifying some products or some families that are the most common, the most common within this industry, and with different kind of capabilities depending on what you want. Sealed with F-class standard, or latching relays. We can help on that. Talking about processing or more smaller electronic components, we should not forget about linear transformers or switching power supplies. We can support with modules, these kind of modules with the capability of provide 15, 20 amps, everything or most of the components in one single package. Inductor discrete solution or discrete components, diodes, for example, or discrete solutions for like regulators or controllers. Yeah, so just another example of what we can help you to. And finally, talking about complementary solutions, connectors. We will find maybe in our components the most simple component like headers, but for more complete or more robust solutions, we can find some other technologies that can help you with for your design. You can find different pages within Amphenol ICC that with different industries, with different implementation that can help you to identify some products that can apply for your requirement for your application. And we can find some other technologies. We can find or we can help you with some other products, some other suppliers, voice detection, command detection. The reason for this webinar is to remind you that we can help you to identify current requirements or future requirements. So we are here to help you. So that would be all for this webinar. I hope the information we shared today was very good for you. We can remember that we can help you with some recommendations. The three of the FAEs or the FAEs for Ion with the support of the account managers or the sales team members are here to help you. We normally use or upload these webinars in our social networks. So we will let you know when they are on our channel. And also we will share this presentation to you.